In this final video, we're going to calculate modified duration from start to finish. This will be our third duration problem that we're doing here. Duration is measuring the magnitude of the inverse relationship between bond prices and bond yields, and modified duration is said to be able to more accurately measure that magnitude. Okay, so we're going to follow the we're going to follow the three steps that we've used to calculate duration normally, and then we're just going to add a fourth step, which is pretty straightforward. All we're going to do is divide duration that we calculate in the first three steps by 1 plus the yield to maturity. So let's do that here. So problem 3, suppose a $1,000 face value bond that matures in 3 years has a coupon rate of 5%. If the yield to maturity on this bond is 7%, what is the bond's modified duration? Okay, a couple of things about this problem. One, we don't specify whether or not coupons are paid semi-annually or annually or quarterly. So we're going to make the assumption that the coupon rate of 5% means that coupons are going to be paid annually. We're going to follow the three steps. We're going to first calculate the price of the bond, which is straightforward. You should have a good grasp of that by now. We're then going to calculate the numerator of duration. It's a little bit messy. We should be able to do that by now after you've seen the other two videos. The third step is finishing up our calculation of duration. The fourth step is just calculating modified duration. It's pretty straightforward. So let's do this here. The coupon rate is 5%. The yield to maturity is 7%. Some of you have already thought about this and know that the price of this bond, or the denominator in the duration formula, is going to be less than $1,000. That's because the market views this particular bond as being more risky than the 5% coupon rate that the firm has specified. To verify this, to verify that the price is less than $1,000, the future value is going to be the face value. It's going to be negative 1,000. It's negative because it's an outflow from the firm's perspective. The payment is also going to be negative, an outflow from the firm's perspective. And this particular firm is going to pay a coupon of $50 in years 1, 2, and in years 3. Outflow. So I have a negative sign in front of it. N is equal to 3. I over Y is equal to 7%. I'm going to calculate the price of the bond using my financial calculator here. Negative 1,000 in future value, negative 50 in payment, 3 years until maturity, 7% I over Y. I'm going to compute present value, and I've assumed that this is going to be less than $1,000. Consistent with our intuition, it is. It's $947 and 0.5137. $947.5137. So there's the price of the bond. That's the denominator in the duration formula here. Okay, let's move on to step 2. This is going to be a little trickier. I'll move more quickly in this video than I have in the past. But I have 3 cash flows that this particular bond will pay out. In year 1, it will pay out a $50 coupon. In year 2, it'll also pay out a $50 coupon. And in year 3, it will pay not only the $50 coupon, but also the $1,000 face value. So year 3, it will pay out the $1,050. So this is what the stream of cash flows looks like over each of the next 3 years. What I need to do now is I need to take the present value of these cash flows. I'm going to take the present value. I'm going to divide these cash flows by 1 plus the yield to maturity raised to the power of t. I'm then going to multiply it by t, and then I'm going to add following the order of operations. So let's do this here. I'm going to take $50 divided by 1 plus r, which is 1.07, my yield to maturity, raised to the power of 1. So there is the present value of the first $50 coupon. I'm going to multiply it by 1. So I've taken the present value of the first coupon and multiplied it by t. Let's take the present value of the second coupon. Again, it's $50 in year 2 divided by 1.07 raised to the power of 2. There's my present value of the second coupon. I'm going to multiply that by t, and in year 2, t is equal to 2. And let's do this one last time for the third year's cash flow, which is $1,050. 1050 divided by 1.07 raised to the power of 3. That's the present value of the 30 years cash flow. I'm going to multiply that by t, and in year 3, t is equal to 3. Okay. Let's do this. Take each in turn here. 1.07 raised to the power of 1 is 1.07. 50 divided by second answer, and notice that it saved my 1.07. I hit equals again, and I get the present value of the first year's cash flow, which is 46.729. Okay, I'm going to multiply that guy by 1, and hopefully you can do that in your head. And so the first present value of the cash flow times t is 46.729. We got to do this again 2 more times. I'm going to start in parentheses for my second cash flow here. 1.07 raised to the power of 2. I'm then going to divide 50 by what I just calculated and multiply it by 2. 1.07 raised to the power of 2 equals 1.1449. Take my $50 coupon divided by second answer, or divided by 1.1449 equals $43.67. This is the present value of the second coupon. However, I need to multiply this by 2 because duration has me times this by the number of discounting periods, times 2. And I get 87.3439. Okay. So I've done this now twice. I got to do this a third time for the third and final cash flow. I'm going to say 1.07 raised to the power of 3 equals 1.225. I'm going to take 1,050, that's the $1,000 face value plus the $50 coupon in year 3. I'm going to divide that by what I had just calculated, 1.225 equals $857.1128. That's the present value of the third year's cash flow. I got to multiply this guy by t, and I get 2571.3383. Okay, so this is my third number that I have to make sure that's right. 2571.3383. I'm going to add up all 3 of these numbers, and I get the numerator of the duration formula. Add that to 87.3439, and add that to 46.729. And I get 2705.4112. And there's the numerator, 2705.4112. So there's the numerator of the duration formula. When I'm calculating duration, I'm just going to take the numerator in step 2, 2705.4112, divided by the price of the bond that I obtained in step 1, 947.5137. $947.5137, and I get a duration of 2.8553. Okay, I'm looking for modified duration. Duration tells us, this duration number tells us that for every 1% increase in a bond yield, this particular bond price will decrease 2.86%. Modified duration gives us a more accurate estimate of the magnitude of this inverse relationship. I simply divide duration by 1 plus r. In this case, it's 1.07. And I should get 2.67. Again, this is giving us a more accurate estimate of the magnitude of the relationship between bond yields and bond prices.